Morning, friends. Hope you all are doing good. So, today's topic is the segment routing over LDP. In the last SR to LDP interaction session, I talked about LDP over segment routing and I talked about what is the requirement of mapping server, where exactly we can place it, and how to configure all those stuffs. But before starting the today's session for the SR over LDP, let's just brief about all four general topologies and let's check where do we need the mapping server and in which scenario we don't need mapping server. Generally, this type of situation arises in your network when you are migrating from LDP to segment routing or certain design criteria where both of your labeling protocol, that is segment routing and LDP, coexist. So R1 and R1, R2 and R3 has their prefix-sid index available in the segment routing domain, and in the LDP domain all the routers including R1, R2, R3, R4, R5 and R6 has the label assignment. So when R1 tries to reach to R6, when you check the LFIP table, it doesn't contain the R6 label information because segment routing only understand the index value. And here in this domain we have configured the LDP, hence we don't have any prefix mapping for R6, R5 or R4, or let's say the devices in the LDP domain. Hence R1 doesn't have any prefixed information for R6 and it will not be able to reach to the R6 or any of the destination in the LDP domain. So when your router populates the routing table, so LDP picks all those routes and assign label value to each of the prefixes and advertise those prefixes to its neighbor, and based on that one say neighbors install that one as a either push or swap in the outgoing direction. So that's the reason LDP has label for all the prefixes, even for the R1, R2 and R3. But as in the segment routing we need to configure the index value manually and we need to advertise into the segment routing domain. But we don't have that configuration on R6, R5 and R4 because those routers belongs to LTP domain. Then we need some external mechanism to resolve this issue. So we need one SRMS, that is segment routing mapping server. It can be the control plane or it can be in the data plane. Even in this case, we can configure R3 as a SRMS mapping server. And then we configure for R4, R5, R6. We configure their prefixes and their index value. Let's say 6. Sorry, for R4 it is 4, for R5 it is 5, and for R6 it is 6. And then advertise them into the segment routing domain into the IGP. For more information, you can watch my previous videos on the segment routing to LDP interaction. And once R1 gets that information, it installs that one into the LP table. And after that, it can easily reach to the R6. So one thumb rule for the mapping server is that, let's say this is the destination and this is the server. If destination is in the LDP domain and source in the segment routing domain, then yes, we need the mapping server. If destination is in the segment routing domain and source is in the LDP domain, then we don't need any mapping server. So on the border router, there is seamlessly interaction happens between segment routing label on and the LDP generated labels. And even in the scenario where your destinations are in the source and destination is in LDP, but the middle island belongs to the segment routing. So let's say you have this type of scenario. In that case also you need the mapping server. But let's say you have segment routing, then middle island is the LDP, and then source is also in the segment routing domain. Then in that case you don't need any segment routing mapping server. So only thing is that if destination is in non-segment routing domain, then yes, you need the mapping server. So if we talk about this case, so destination R6 is in the non-segment routing domain. Hence we need the mapping server entry so that R1, R2 and R6 can install the segment routing label for the R6. So in this case, so let's say this is the source and this is the destination. In this case, source is in LDP domain and destination is in the segment routing domain. So here R1, R2 and R3 takes the route from the routing table and assign labels to them, all of the prefixes labeled to them, and advertise them to their neighbors. And if you check the segment routing domain, so you will have the prefix index for R3, R4, R5 and R6. So when packet reach to the R3 with the LDP label, seamlessly it interacts with the segment routing label. So whatever, let's say X label R2 receives, R3 receives from R2, then it will be seamlessly push that with 16006 label. This operation happens seamlessly and we don't need to do any external configuration. But challenge is that in this situation also you will need the SRMS. Now you could be confusing why. So from if you want to move from R1 to R6, your operation is happening seamlessly. But when R6 wants to reach to the R1, then your connection is broken. So in that case, you need SRMS to advertise R1 and R2 entries into the segment routing domain. Let's talk about this scenario where traffic is moving from segment routing domain to means source is in the segment routing domain and destination is also in the segment routing domain, passing via the LDP domain that we called as a segment routing over LDP. So in that case, 16,000 16,006 entry will be seamlessly mapped with the LDP label which R3 got from R4. And here again, whatever LDP label is there, it will be seamlessly mapped with the 16006. But as this is directly connected, so here it will be pop operation. As we discussed earlier, here both source and destination is in the segment routing domain. Hence, we don't need any segment routing mapping server here. So the transition between segment routing and LDP is happening seamlessly here, and we don't need any external configuration to achieve it. But if we talk about the LDP or segment routing, where LDP source is in the LDP domain and destination is in LDP domain and going via the segment routing domain. Middle domain is the segment routing domain. Let's say packet reach to the border router R3, but R3, R4 and R5 don't have any prefixes for the routers which are in the LDP domain. To achieve that one, we will need the SRMS, which can advertise the R1, R2 and R6 entry into the segment routing domain. And then there will be the end-to-end reachability between R1 and R6. So this is how the SR to LDP interaction works. So let's talk about the SR over LDP. So let's jump into the lab. So on the right hand corner side, you can see that lab diagram where R1, R2, R3 and R6 are part of the segment routing domain and R3, R4 and R5 are part of the LDP domain. So I'm running the ISIS between all the nodes. So you can see that R1 has adjacency with R2, R2 has adjacency with R1 and R3, R3 has adjacency with R2 and R4, R4 has adjacency with R3 and R5, R5 has adjacency with R4, R6, and then R6 has adjacency with R5. If we check about the LDP, so on R1 we don't have any LDP, R2 we don't have any LDP, R3 is running LDP with R4, so this is acting as a border router between segment routing domain and LDP domain. R3 is running R4 is running the LDP with R5 and R3. R5 is running LDP with R4 and R5 is acting as a border between segment routing and LDP domain. And we don't have any LDP on R6 as well. So if we check the database on R1, so this is the index value 1 for R1 node. This is the index value 2 for R2 node. This is the index value for R3 node. We don't have any segment routing related information for R5 because that is part of LDP domain. For R5, this is the prefix-sid index, and this is the prefix-sid index for R6. So if we check the label table for that, you can see that we have the segment routing calculated labels for R1, R2, R3, R5, and R6. And if we check on the R4, which is running the LDP, we have the LDP bindings from the remotes. So let's try to trace route to from R1 to R6. We can see that R1 has pushed the 16006, same level swapped by R2, R3 which is acting as a border node, which is seamlessly pushing the label between segment routing domain to LDP domain. Then R4 is swapping the LDP learn label which he got from R5, and then R5 is directly connected to R6, hence it is penultimate hop popping. So if we check the prefix entry, so this is labeled SR. So whenever you are troubleshooting segment routing related issue, so first you need to verify that this particular route should be marked as a label SR. So this is marked as a label SR. This is the local label and this is the impose label or outgoing label. So this is what we are checking the label for prefix 10666. So we can see that local label is 16006 and outgoing label is same label 16006. So same entry you are going to see on R2. And if we check the safe entry, it marked as a label SR and outgoing label is 16006. But if we check on the R3, which is border router, we will see some difference here. Local label is 24004 and outgoing label is 24003. It marked as a labeled SR. So you might be surprising, it should be the received label should be the 16006. No, but this is running the LDP as well. So if we check the MPLS table entry, here still you will see that LDP populated prefixes, but so here you will see the proper matching. So the packet from R2 we are getting with the label 16006, and then R3 has programmed the LDP learn label which he got from R4 24003, and it is seamlessly mapping between the SR domain to LDP domain here and sending packet towards R4 with the label value of 24002. So if we check the LDP binding which we got from the neighbors, so this is the 1610.6.6.6. So this is the label which we got from R4. So if we check the entry on R4, this is the LDP labels, LDP generated label. So you don't see any labeled SR information here. So this is the local label and this is the outgoing label which he got from R5. So R5 is border router again. R3 and R4 both are border router. So it marked as a label SR here, and then local label is 24006, that this is the label which he is expecting packet from R4, and then outgoing label is implicit null which is penultimate hop popping. So if we check the entry for this prefix LFIB entry, this is implicit null. If you check the label you will get the same information 24006, and it is popping the label and it is sending it to the segment routing domain. And if we go to the R6, that is the final destination. This is how it is the SR or LDP works seamlessly without any external configuration. And if we do the trace route SR-MPLS source, so you can see these are the segment routing labels, these are the LDP labels, and this is implicit null. So in this scenario, we don't need any external configuration because interaction between segment routing and LDP works seamlessly here without any external configuration. But if we talk about the LDP or segment routing, then in that case we need the mapping server because it is going via the middle island which is segment routing, and in that case segment routing don't understand anything beyond the prefix-sid. Means if our destination is in the non-segment routing domain, then we need the segment routing mapping server. That is the thumb rule. That's it for today. Hope you enjoyed this session and thank you very much for watching it.